Good afternoon. Thank you for joining this webinar. We'll be talking about water today. So huge issue continues to be we're not out of the drought, and today we're going to be talking about LA's water future. Some great data that's come out about the energy water nexus, which is a big topic of discussion, something that we really are only just starting to understand in a meaningful way. Look at some of the city's goals around water, increasing local supply, reducing our dependence on imported water, and then how do we be smart, how do we be efficient with what we have, and talking about some resources to help you identify opportunities. Of course, there is an ordinance now that's requiring us to at least take a look at that and work towards some targets. So it's going to be a lot of content to cover today. As usual, this is being recorded and will be available on our website. We'll also circulate a link to the recording to everybody who registered. See that along if you like. Lines will be muted to keep things orderly as usual, and please do send any questions on the content or things that occur to you today via the chat box, and we will make sure to cover those at the end. We have great speakers today. Dr. Katie Micah, she is a policy advisor to the mayor and has been doing some fascinating research that she's going to talk about today. And what is, LA's water future? What is going on? And Mo Urbesnik is water technical advisor, our in-house expert here at the LABBC. Is going to talk through some new tools and resources that we've developed here to help, again, identify opportunities, think through the different options, look at what's available and could make sense for your property. So great content today. And with that, I will hand it over to Katie to talk about local water in LA.
So much, Dave, for the intro. Sorry, it took me a second to find the mute button. I'm really happy to have the chance to be today and talk to you all about the exciting things that we're doing in water, looking at how we can start to increase our local water supply and think about how we can move towards a more sustainable water future for Los Angeles. I'd like if we start with an overview of where LA gets its water. Right now, between 80 and 90% gets sourced from, depending on rain and snowpack, gets sourced from water coming from hundreds of miles away. By water from Metropolitan Water District, which imports water from the State Water Project, which comes from the Bay Delta area, as well as the Colorado River Aqueduct that brings in water from the massive Colorado River watershed. LA also has its own source of water that comes through the LA Aqueduct, hundreds of miles from the Owens Valley, Mona Lake area. And one common thread between all of these imported water sources is that I look forward to a potential changing climate future with low snow potential, perhaps snow that's melting earlier, more falling as rain. All of these sources will be reliable going forward. And so we're really starting to shift and think about how in LA we can source more of our groundwater, more of our water locally. And when we're talking about local water in LA, we're really talking about how we can use our local groundwater basins to a greater degree, how we capture more stormwater, both to recharge the groundwater basins and to use that water on site, how we recycle and reuse more of our wastewater, and then also equally important, how do we reduce demand for water in LA so that we can start to think about how to bring less water to Los Angeles in general. So one of the interesting nexuses for us in Los Angeles is that as we look at our water sources, the water that comes into the city from sources in the Bay Delta area and Colorado River Aqueduct are also the water supply sources that are the most energy intensive for us. As we're looking at increasing our local water supplies, we're also significant impacts on energy footprint of the water that we're bringing in to our city to supply Angelenos with water. And that the water energy nexus that Dave mentioned earlier is a really important and interesting piece of the puzzle on how we can think about how we can reduce energy alongside of getting a more sustainable local water supply. That's not true across the board for all sources that come in. As you can see, the LA Aqueduct has an intensity of 0, and depending, there's some hydropower generated, so depending how you look at it, it could even be an energy positive source that's really all gravity fed, which is a pretty incredible engineering feat. So it really is about pumping water in to the city over the mountains that you see the high energy footprint on grid water sources to the right. But just to note that it's a really great way to think about reducing energy to our water footprint. And then on the next slide, the direct link between thinking about saving water and saving electricity in California. This really neat research done out of UC Davis looking at the impacts on electricity savings from Californians looking to save 25%. Conservation involved 25% water savings statewide. So we were at 24% of our water savings, achieved % of our water savings across California, and you can see that had a really significant electricity savings as well. The water savings corresponded to more than 1,000 megawatt hours of electricity saving, and that corresponded to 200,000 metric tons of CO2 equivalent. So it's also got really significant greenhouse gas emissions and shows the importance of saving water, not just to save water, but also as a way to save electricity. And the greenhouse gas emissions were equivalent to taking almost 50,000 cars off the road for a year. So Water and Energy Nexus is a great opportunity to think about creative solutions that will help us move regional towards local water and renewable energy goals. Also at property levels, think about how we can get to savings on water and electricity as well at that scale. How are we going to go about what we have in the state plan in the city of Los Angeles is we've set some really ambitious goals to source our water locally. So at 2025, we're going to reduce that imported purchases from Metropolitan Water District by 50%. And then further out to 2035, we're going to be sourcing 50% of our water local Los Angeles. So again, and then if we're now in the sustainability plan process undergoing a refresh, where we're looking at new partnerships and where these goals can be updated, how to be changed. They've been really successful in driving some of these scenarios. How do we change the landscape of LA's water and source water more locally to meet these goals? And we're in a place where we're thinking about other additional opportunities to do more of this. Today we're talking about water, but this is the plan rush is all the chapters in energy, air quality, housing development, and a wide variety of topics. So can I go?
Can I ask you a quick question on this?
Yeah.
So reducing imports 50% by 2025, and then sourcing locally 50% by 2035. Could you just clarify the difference between reducing imports and sourcing locally? Is the reduction in imports driven through efficiency, or what's the difference between reducing imports and sourcing locally?
Sure, and let's move to the next slide for that, for a pie chart to talk about. So the main difference that is that is really just buying less water from Metropolitan Water District. So the difference there is the City of LA purchases water from Metropolitan Water District. That's that the first 50% goal is reducing. If you look at the pie on the top left, that MWD water piece of the pie is our purchased imported water. And it's the water coming in from the Bay Delta and from Colorado. And the more that we can bring sourced water, the less that we have to purchase from Metropolitan Water District. So that's where do we bring water in? Where if you look at 2025, that Metropolitan imported water goal has been reduced by half, and that's the first one. And we go forward, switching that to sourcing our water locally. And pretty, but I'll try to be clear, and please ask any other questions too. But we got local 35. The imported pie chart there now includes both the water from LA Aqueduct and water from Metropolitan Water District, because at that point it's based on the distance that it's coming in. So the LA Aqueduct water is still LA water, so we're not purchasing it. It is part of that first 2025 goal to reduce imported water, purchase of imported water. But in 35, when we're really thinking about how we can source water locally, and locally meaning really things that are pretty close to Los Angeles. So how are we capturing more stormwater? How are we recycling more wastewater? How are we using more of our groundwater basins? And then that's where we are thinking about sourcing 50% of water locally. But import is both purchased and non-purchased, just based on how far it's coming to get into the city.
Thanks, a lot clearer. So the LA aqueduct water in 2035 gets combined with MWD, even though it is basically.
Right, because it's just kind of a switch to thinking about local water as really truly local water.
Right, drawing a distinction.
Yeah, the first one is how do we reduce those purchased imported water sources. The interesting thing to note, as we're looking at sort of the new local source water pieces of the pie, that's also including some water conservation as well. The reduction in demand is also kind of part of this low water supply idea of how we build water resilience in Los Angeles.
So kind of WP is looking at energy efficiency as part of its, quote, power mix, trying to meet customer demand through efficiencies. And
then these land goals that are also in DWP's urban water management plan. So these their water management plan as well. And there's some really good breakdowns in that document, kind of on the specifics of how we're thinking about going into really aggressive. I mean, we're looking at really significant changes in how we're sourcing water to Los Angeles.
Great. And if interested, we can include a link to that in the follow-up to the webinar.
Sure. So, I just talked about a little bit on that pie chart. One of the other ways to really think about building water resilience in Los Angeles is how we can reduce it as well, because LA is already a success story, success in water conservation. We've been serving water here for decades, and DW has offered rebates for many years around different types of technology, how we can get more water efficient appliances in, thinking about how we can transition how we water our outdoor landscape to irrigation that's much more efficient. Also, the new technologies and how those can go in. Metering is one example, and thinking about building, how do people respond if they can see how much water they're using and how they compare to similar properties nearby. And landscape is still about 15% of our water demand in Los Angeles, so there's a huge opportunity really across all property types about transforming our landscape in DW in the city of LA. DW has a really extensive landscape transformation program and offers a rebate to transform turf into different lands friendly, so climate appropriate and sustainable. And one of the really cool things about the program now is it also incorporates a need to capture stormwater to qualify for the rebate. So it's not only saving, it's not just on saving water, but also on how do we start capturing more water for reuse on site, and things that are also watershed friendly, like mulch, for example, where you're getting water quality benefits as well as water supply. And I think an exciting shift kind of in the water landscape throughout is thinking how things can be multi-benefit and really offer a lot of advantages to programs that you're doing. The drought campaign, briefly, we launched a few years ago during the drought, and it was really, and just sharing with everyone how important it is to save water. Raise awareness around the fact that conservation in California is really a way of life, and we need to think about how we can start to do things that will last for a long time going forward, not something that will kind of wrap up as a drought ends. And shift the California and locally is thinking about this water conservation as a way of life. This slide was a little bit more focused on things on residential property. On the next and last slide, just to talk a little bit more specifically about some of the cool opportunities in the industrial institutional sectors. One really cool program LABBC has that can provide some funding for creative solutions to conserve our water is their technical assistance program, which offers $1.75 for every 1,000 gallons of water saved. The first 4 years up to 250,000. The LOD is determined case by case, and it has to be pre-approved before construction. You can reach out to WP to get more information on that. And kind of a parallel program is Metropolitan Water District's Savings Incentive Program. That's about 60 cents for 1,000 gallons of water saved. It needs to be a project size. And then the last thing on saving the drop to raise attention to is there's an initiative, an LABBC initiative that was launched a few years ago as part of the Save the Drop campaign. That's an opportunity to save $100 million, to join in a program that will eventually, the goal is to save 100 million gallons per year in large commercial buildings. And then the kind of exciting thing to talk about on that is that Mo is going to talk about later is how to, there are a lot of properties in Los Angeles and different parts of the city, like Hollywood and Westwood, where there's a need to dewater groundwater from the buildings all the time. And that is a really exciting opportunity to start thinking about how to cut water and reuse it on site, for example, in cooling tower water. So water dewatering is an area that has a lot of potential when looking forward and thinking about opportunities to do things that really move the region and local areas around meet our local water and energy savings goals, and also how we can move local energy and find really great ways for partnerships between city partner groups and residents and building owners to think about how we can approach these things all together. So really, there's a lot of really exciting synergy opportunities here. We look forward to the future of water in LA. Oh, I had it, sorry. And then just to say briefly that this ordinance, the EV/EWI ordinance, is an exciting thing. I'm going to leave mostly for talk about more, but just to say that it has water benchmarking requirements in it that give us a really good opportunity to understand how water is being used and where there are opportunities to save water. It also includes water audits and retro commissioning, and it's a great way to measure and track water reduction at different and buildings of different sizes in the city of LA, and is a great partnership opportunity as well.
Katie, that was really interesting, and I'm sure we're going to get lots of questions. One thing that I wanted to point out was in the context of the ordinance, there is this energy water nexus, and it's not just at the state level when we're looking at, massive pumping infrastructure. It's true at the building level too. Improving efficiency, getting more cycles of concentration out of your cooling tower, and better performance out of your HVAC, it has energy benefits as well, and that shows up in the data. So I think and it only makes sense. The less water you're pumping around, the less it uses. The less energy it uses. Talk more about the specific requirements of the ordinance, but something that's coming out that's really interesting is now, 2 years into it, for the large buildings, that is, we have 2 years of water benchmarking data, which has never existed. It's a very unique data set, and so we're starting to dig into that, look at patterns by property type and year-over-year trends, and some surprising things coming out, some things we kind of knew intuitively, but collaborating with EPA to actually turn that data into a benchmark, a score, for different types of properties, which is new, and it's thanks to leadership from that we're generating this data, and it's really valuable for people to see. If anyone has any questions on that or water audits and retro commissioning, we will be doing trainings on the standards that are coming for that, and that will be later this fall. So with that, we'll transition over to Mo or Besnick, who's going to talk about some of the resources that we've developed, and this ties back to the incentives that Katie was speaking about, some of the opportunities with landscape transformation, shifting towards local water, dewatering. So I'll turn it over to Mo to talk through what we've developed, how it came together, and first, kind of where the ideas came from. So Mo, I'll turn it over to you.
Great, thanks, Dave. So, where came from? Well, obviously, at the Better Buildings Challenge, our focus is on commercial and multifamily properties, and these use a significant amount of water, and there's a strong business case to be made for use efficiency. So we have come up with some tools to help customers identify, assess, and implement water use efficiency projects. And so we'll just looking at one of the major water uses of water at commercial properties. Number one, it's rooms. Two, cooling and heating or cooling. Three, irrigation if you have irrigated landscape at your site. And four, kitchens. So use vary among sites, but unless you have a highly specialized activity at your site, your top uses will fall into these same categories. And if you are a low-rise multifamily property, your top will be plumbing, irrigation, and laundry. Next slide. Expected, the water savings measures with the best return on investment match the top uses. Cooling to water treatment, installing high-efficiency plumbing fixtures, and upgrading your irrigation system. Next. So one opportunity for most commercial properties is upgrading your cooling tower water treatment, and LABBC worked with industry folks to develop for not only cooling towers, but each of the top measures. Walk owner managers through potential recommendations, a range for the upgrade, and appropriate installation conditions, available incentives, typical payback, and considerations when assessing your property for the upgrade. There will be more information of where they can be found at la-bbc.com later in the presentation. But so cooling towers. In general, there are four major types of upgrades for cooling tower water treatment. First, just increasing your cycles of concentration with standard chemical treatment and better monitoring. This is good for most towers when water quality is better and there may not be on-site maintenance on staff. LADP offers $625 for the installation of a connectivity controller, which should cover the cost of the controllers, and payback should be it. So see, the primer will walk you through this same sort of information with a bit more detail. Next is acid and partial acid treatment, which is sometimes called pH or pH trimming. Acid is incorporated into the water treatment, increasing the cycles even above standard treatment to 4 or 5 cycles. You'll install a pH controller, and DWP offers $3,000 per controller. Again, the payback should be immediate. Careful consideration should be given to handling of acid. There's partial acid treatment, which is more convenient and a lot less risky, and that's what most properties are moving towards. Next. An option is pre-treatment of water through softening to remove hardness and up the cycles to 7 or 8. This usually makes sense for larger towers. It does require space for the softener and resources to monitor the system and add salt. And there's water softening on steroids, or what they call zero liquids discharge, which uses silica in the water to manage the total dissolved solids and the system to significantly increase cycles and many times eliminate the bleed. And there's an emerging technology that's being piloted at City Hall East that is dynamic water's electrochemical water treatment. Water is fed through reactors. Calcium and magnesium are collected in the reactors and disposed of, and because of the water chemistry, chloride is produced thereby requiring no chemicals. In LABBC's September webinar on the 2nd, Dynamic Water will be presenting their City Hall case study. So technologies are available or eligible to receive LADWP's TAP incentives that Kate discussed, which offers the $1.75 per 1,000 gallons. And if more than 1 million gallons is saved per year, you're also eligible to MWD incentives of 60 cents per 1,000 gallons. We are also these are available to help customers evaluate these opportunities at your site. We are for plumbing. Restrooms are the top water user at most sites, but many of you may have already upgraded your restroom. If your building is older than 1992 and you haven't replaced your fixtures, this is a great opportunity. If you have replaced your fixtures in the last 10 years, the incremental savings may be minimal, and the potential performance issues might not make it worthwhile. We'll walk you through the best in market fixtures, again, the price range, available incentives, savings, payback, but for toilets, we all love talking about toilets. Tank type toilets, the best in market is as low as, oh, I think you went, Bill. Just quickly, so there is 5 gallons per flush for type. Hundreds of thousands of those have been installed so far. Performance is proven. If you have a multifamily site, you should consider this upgrade, especially while the incentives are still available. For valve type toilets, the best is 1.1 gallons per flush. But for buildings with valve type toilets, special consideration should be given when deciding whether to move to the best in market design of commercial building. The fact that there's limited wastewater from showers, baths, washers, etc. The best in market may not perform well. So we recommend piloting new technology. LADWP offers significant incentives, $250 per fixture. Use watersmart.com, which can result in or 1 to 3 year payback depending upon your product. Performance reviews at things at map.testing.com, and EPA has a list of certified models, which is also a requirement for the rebate. For urinals, there are 3 predominant types of urinals available in the market: 1 pint, 0 water, or the hybrid urinal, which flushes 1 gallon every 72 hours to address calcium buildup in the pipe. LAD offers $500 for any of the fixtures using 1 pint or less, and with a substantial incentive, again, payback is immediate to 3 years out. EPA has a list of water sensor models, and we always recommend piloting new technologies. Faucets can go as low as 0.5 gallons per minute for public restrooms and 1.0 for residential applications. Showers as low as 1.2. Again, EPA provides certified lists. Programs available from LADWP. LADWP will give you free product, or if you're a multifamily site, you can get free installation through the SoCal Direct Therm program. So plumbing's pretty straightforward. If you have substantial irrigated area at your property, irrigation is probably the second best opportunity. The primer reviews all of the opportunities with taking into account really the special considerations for irrigation. So a bit more complicated. Their building owner really has 3 water efficiency options with varying save levels. 1, install smart irrigation technologies. 2, you can reduce some of your lawn. 3, you can reduce all of your lawn. You'll need to test your site, your company, and consider several factors making the decision. Do you need area for recreation? How old is the current system? Is it time for an improvement? Do you want a traditional landscape? Do you want a modern look? Do you want a sustainable look with rain garden? All of these impact your upgrade. By installation of smart irrigation. So here are the industry best practices, which are outlined in the primers. Smart-based controllers that set the schedule based upon local conditions, soil type, plant type, sun versus shade, and adjust the schedule for the local weather. Saves water, but as Kate said, it also reduces runoff, gives the plants the correct amount of water. We have high efficiency nozzles that reduce flow, but with improved technology, deliver water in bigger drops and provide more uniform and better coverage. Spray heads with check valves which regulate pressure and eliminate waste and low head drainage, and master valves and flow sensors sense abnormal flow, and when detected, turn the irrigation off, which if you install with a cloud, the smart controller can send alerts to owners and operators. So decision on which path to choose for your property: irrigation upgrade, turf removal, what % of turf, rainwater catchment. But what LADWP does offer incentives. LA offers $50 per station for smart controllers, $6 per nozzle, and $2 per square foot for turf removed up to 10,000 square feet. You can call water.smart.com. And as Kate talked about, lastly, There is a large opportunity to use nuisance groundwater at your site if you are currently pumping to the storm drain or sewer. Use that to offset uses such as your cooling tower water feed. We have developed here a roadmap to assist you in evaluating your options. First, you need to determine your actual discharge amount, test the quality, match it with whatever end uses you have, and your project. And we're here at LABBC, the team, available to conduct site assessment and assist you in evaluating your project.
Thank you. And Katie, this was a lot of information that we covered in a short time. Make also efficient use of everybody's time. So that information, here's where you can get it. So this is the website where you can download copies of the cooling tower primer, the plumbing primer, the irrigation primer. We'll be releasing the dewatering roadmap here next, actually tomorrow. The mayor is going to be doing a press event at a really exciting landmark project at Cedars-Sinai, where they're reusing over 20 million gallons of groundwater as makeup for their cooling towers. Obviously, huge campus, huge cooling loads at a facility of that type. So again, the primers that were developed are based off of conversations that we had with actual projects. So the costs are recent, they're based on real numbers. And EPA have great resources to help you actually specify the fixtures. And as Mo said, you know, we're available as a resource to talk about bigger projects like cooling towers, like dewatering, like these big decisions around irrigation systems to help navigate this whole process. So with that, we'll open it up to questions. Mo, I have a question about cooling towers, so just go back to that real quickly. What should I do if I'm interested in cooling tower upgrades?
It will be working with your current water treatment vendor, collecting your water treatment reports and understanding what type of treatment you have and what cycles of concentration you're at, your water quality, and then discussing with them what opportunities you have for making upgrades specifically at that site.
Thank you. Katie, going back to the plan and some of the initiatives that you discussed there, what are some examples of how the city is moving towards local water?
So several towards local water. There's some large-scale examples on thinking about how we can reuse more of the water in our groundwater basins. There's historically been some contamination of groundwater basins in and in January, the city broke ground on North Hollywood, one of the remediation facilities in North Hollywood. That's one that are planned to be able to clean the groundwater in those basins to be able to fully use it. That one project will supply enough water for about 35,000 homes once it's done. So that's an example of a project on how we can collect more water from the groundwater basin safely and clean. And then the other piece of that puzzle is how do we get more water into the groundwater basins to recharge them so that we can extract and use that water. And that's where things like recycled water projects, capturing more stormwater, they start to play important roles as well. There's, as part of meeting that 50% of water sourcing 2035, there's 150,000 acre feet per year goal for treating more stormwater. And the city has a lot of different activities in place, like working county to recharge or to have spread grounds be rehabilitated to be able to capture more water when it does rain. A lot of things going through the surfaces, smaller scale distributed projects to capture more stormwater, and some recycled water projects, for example, at Tillman Water Reclamation Plant, to start reaching more groundwater basins up there as well. So there's several different efforts on really ramping up each of the different pieces of local water supply to make a whole.
And does that treated groundwater need to go to purple pipe, or how does it make its way into our homes and workplaces?
That is water is to be drinking water treatment facilities.
Interesting. Great. A question about plumbing fixtures. What I don't know, how do I know if my plumbing fixtures have been upgraded? Like, what would I look at, I think is the question, to determine plumbing fixtures have been upgraded or not?
The plumbing primer does have some tips on how to identify the gallons per flush of toilets and urinals. Usually they are stamped on either the valve or the porcelain at the back for a toilet towards the hinge of the seat or on top of the urinal, and it will tell you the GPS.
And what's the kind of cost-effectiveness cutoff these days? Like, if I look on the valve or on the back of the porcelain and I see it's 1.6 gallons per flush, does it make sense to look into replacing that, or kind of what's minimum gallons per flush where it makes sense to look at this?
Minimum is 1.6. If you run a replacement in the last few years, you're probably at 1.28, and that incremental difference to 1.1 is not going to make that big of a difference. And there, like we talked about, there could be potentially performance issues at your site. But at 0.6, it's going to be site dependent. What does the installation look like? Where's the sewer line? Where's the tile, the placement, product, footprint of actual fixture? So I would say 0.6.
Great. Back to Katie. How does stormwater capture help us move towards water quality and water supply goals?
So I foreshadowed that one a little bit. It's a really important. We are fortunate in LA to have groundwater basins that we can store water in, and so the stormwater that we're able to capture as it's coming into the watershed to the ocean is water that we can capture for on-site reuse where it makes sense, through cisterns or those kinds of things that can help offset water demand in different properties, but also to recharge water basins for use areas, depending on where it is falling in the LA area. And also, these stormwater capture products are another area where multi-fit benefits come into play to a very degree, because we're getting there can be parks that have sterns. There can be a lot of green infrastructure that provides shading and amenities that are also kind of greening LA. But the biggest benefit from water projects is that it's really helping improve the water quality in our local water bodies. So the more stormwater that we're able to capture in the watershed, we're all preventing pollutants being carried into LA River, out to the ocean, for example. So it's helping clean up our water bodies and at the same time helping us with these local water goals by storing more water here for us to access or to help offset some demand in different places.
So bigger picture, but I think interesting in context of our conversation today. A question about groundwater reuse, and we will be, as Mo mentioned, featuring the Cedars-Sinai in our next month's webinar. But if you could talk quickly about, you were privy to it, Mo, the kind of permitting process and thinking about drivers for the project and kind of water quality can determine the type of system and end uses for that water. I know we'll go this next week, but if you could briefly touch on that.
Yeah. So when you're discharging to the storm drain, you have a permit through the regional quality board. You have to test that water for disturbance, and you don't fit within those parameters, you can be fined. There have been when entities are being fined, you know, it's $2,000 for every time that you don't make or don't fit within the parameters. And that can really make your ROI change. I think Peters was looking at fine in their water quality. But one of the things they looked at was that was a determining factor in actually eliminating any storm drain and going directly to sewer. And when you do have to do that, you do have to get a industrial discharge permit from the sanitation, LA sanitation.
Right. There is some process with that, but it's established and it's not totally new for sanitation. And I think a point to emphasize there is that the kind of the composition or the quality of the groundwater is it's not the fault of the building sitting on the site, what's in there, but there can be, you know, different costs associated with that, and I think that's important for that to be included when we're looking at the return on investment of these types of projects, is those, you know, avoided treatment costs and permitting costs. So I wonder how it'll be interesting to see how that could factor into the ROI of that project, since I know that was a significant driver. Excellent. Well, I don't see any other questions coming in, so I want to thank our speakers today. This was fantastic. And next month we'll be talking about some case studies on innovative water conservation efficiency projects and examples of what's possible when you put these technologies and best practices into action. All of the resources that we reviewed today are available at betterbuildingsla.com, and we'll be sending around a link to all of those, along with a link to the DWP Urban Water Management Plan that Katie alluded to earlier as well, in case anyone wants to dig deeper on that. And look out for updates to the Sustainable City Plan. The refresh process is going on now, and the Mayor's Office is convening stakeholder groups to help refine, refresh, look ahead, look again at the goals of the plan and our progress towards those. So thanks, everybody, for joining this afternoon. I hope you enjoyed it. I found it really interesting, and we'll see you next month. Thank you.
Thanks so much.